Our planet has an average radius of 6,371 kilometers. Using this value, we can determine the volume of the Earth, which we will call V1. Genesis 7:20 tells us that the mountains were covered, so we know that at a minimum, the floodwaters were equal to or greater than the highest point above sea level. So, in order for us to figure out the amount of water required to cover the tops of the mountains as the Bible describes, we need to find the volume of a second sphere. We know that Mount Everest has a height of 8.85 kilometers. It is the highest point on Earth above sea level. We add the average radius of the Earth to the height of the highest point above sea level, and we get the radius of our second sphere, which we will call V2. Since we are trying to calculate the difference between V1 and V2, we subtract the latter from the former. The remainder is the volume of water required to raise the sea level to a height equal to Mount Everest. Using these values, we can calculate that over 4.5 billion cubic kilometers of water is required. But numbers this large are hard to conceptualize, so we need something to compare it to. Imagine, if you will, all of the water on our planet as a single, gigantic drop. Experts estimate that the volume of this drop would be 1.36 billion cubic kilometers. The amount of extra water that would be needed to flood the world is considerable. In fact, we'd need 3 1/3 more drops. In other words, the water on our planet would have to be 4.32 times what it is today. There is no naturalistic explanation for where this extra water went. If the Great Flood was caused by a comet, or an ice shell, or by subterranean springs, or even continental movement, then the water would still be here, but it isn't. If it were still here, the world would still be flooded.